Okay, next we are answering question 4 of assignment 1 here. I'm gonna be breaking this down into 2 videos because it's a long question. On this video, I'm gonna answer A, and on the second video, I'm gonna answer B. For A here, we are given this compound here and this one, and we're told that they have this structure here, which is sodium chloride, and their lattice parameters are given in angstrom here, and we're also given the wavelength here in angstrom as well, and we're told to calculate the two theta values for the first 4 diffracted peaks. So the first thing to note here is that we're given 2 compounds. We're given AgBr, which has a lattice constant of 5.77 for 8A like this, and we're given Ag silver chloride. Its lattice constant is 5501 angstrom, and we're going to have to find the two theta values for both of these. So this is basically 2 parts in one question. So basically here, what we are being told is that this thing has an sodium chloride structure like this, right? If you remember correctly in our notes, this sodium chloride is FCC, right? It has an FCC structure, meaning if it has an FCC structure, then its diffracted peaks are as follows. If you remember correctly, the conditions for the peaks for an FCC structure as follows: H, K, and L are all even or all odd. So in our HKL values, we're gonna have all even and all odd values. So I'm gonna draw up a table here of our HKL values. Oh, let me see. I'm gonna start with the number of peaks. I'm gonna say number of peaks here, and on the next one, I'm gonna have our HKL values, and on the last one, I'm gonna have, let's say we're looking for 2 theta, right? I'm gonna have the D spacing, and I'm gonna have our 2 thetas here. So for the first peak here, we are going to say, since this rule here says all have to be even or all have to be odd, H, K, and L have to be all even and all odd, we are going to write 1, 1, 1, right? That's our first plane. Remember, 1 is an odd number, right? But you can't write 1, 0, 0 because 0 is even. It's strange, but somehow 0 is even. This is because, let me see if I can try to explain this one. An even number is basically a number that is divisible by 2, right? 0 divided by 2 is 0, meaning somehow 0 is divisible by 2, meaning it's an even number. It's kind of strange, but that's how it works. Next, we are going to look at peak number 2. At peak number 2, we can start with 2, 0, 0, right? You remember all these are even. 2 is even, 0 is even, and this one is even as well, right? Our third peak is gonna appear at 2, 2, 0, right? That's going to be our third peak. And then for our fourth peak here, you can be tempted to say 2, 2, 2, right? Yeah, right. 2, 2, 2, which is all even. This is technically correct. But remember, if we have 2, 2, 2, it means this one is equivalent to 1, 1, 1. Remember, right? These 2 planes are equivalent, and we already have 1, 1, 1 here. So we have to move on to a new plane, right? We can't include this one. That's why we have to skip 2, 3. Speaking of 3, we have 3 here, and we can't say 0, 0 because 0 is even. And then here we have to say 1, and also here we have to say 1 because these are all odd. So our first 4 peaks are as follows, right? I'm gonna try to draw our table here. Draw our table like this. It starts with dun 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 dun. Okay. There is our table. There. Complete. Our table is complete. So next, what we need to do is calculate the D-spacing of each peak. So this one, I'm gonna start with the first one. Let's see. Since we have 2 compounds here, we have this first one here and this second one here. We're gonna start with this one here. So I'm gonna say for AgBr like this, we have what our lattice parameters. A is equals to 57748 angstrom like this. So we have to calculate our D spacing for this one here. So I'm gonna say the D HKL, right? And remember, this one is for this one. We have A divided by the square root of this one, K plus L, right? And then in here, we're going to substitute our A, which is 5,7748 angstrom. We divide that by our first plane here, which is 111. We're going to have 1 squared plus 1 squared plus 1 squared. And we're going to have the following. When we put that into a calculator, we're going to have 3,334, which is an angstrom. Once we have our value here, I'm going to go put it in here, which is 3,334, right? That's our value. So for our 2 theta, we are going to have the following. I'm going to say for our 2 theta, we're going to have n lambda is equals to 2d, the sine of theta. And then in here, we're going to have 1. Remember, our wavelength is given as 0,15418, 548 angstrom, and we have 2d, the sine of theta. We're looking for 2 theta, so we are going to say the sine of theta is going to be 0,15418 angstrom divided by 2, and our d, we have to substitute that in. Our d is given, we calculated it to be 3,334 angstrom, like this. And then we're going to say theta is equals to the arc sine of this. I put this one into a calculator. I have 0. That's going to be 0,02312. I'm going to say the arc sine of this is going to be 1,3249. And we're going to multiply that by 2, because if you remember correctly, we are looking for 2 theta, not theta. So 2 theta is going to be this multiplied by 2, which is going to be 2,65 degrees. That's our first value, 2,65. I'm going to go up here and say 2,65. That's our first 2 theta value. Okay, please remember that these calculations are for the first compound here, which is silver bromide, this one here. So we're going to look for the second peak, right? So we're gonna say for the second peak, which is 200, we are going to say that the DHKL is going to be A divided by the square root of H squared plus K squared plus L squared, like this, right? And then we are going to say our A is given to us as this value here, 5,7748 angstrom, and we're going to divide that by the square root of 2 squared plus 0 squared plus 0 squared, and from that we're going to get the following: 5,7748 the square root of 2 squared plus 0 squared plus 0 squared, and that will be equal to 2,8874 angstrom. And we're gonna calculate our 2 theta with the following: 2d, the sine of theta, and then I'm gonna say the sine of theta is going to be divided by 2d, right? And in here we are going to have the following: sine of theta into 1 and 0,15418 angstrom divided by 2 into 2,8874 angstrom, like this, right? And then from there we're gonna have theta is equals to the arc sine of the following. Let me punch this one into a calculator. We're gonna get 0,02668, like this. And the arc sine of that, the arc sine of this is going to be 1,5299 degrees. And remember, we're not looking for theta, we're looking for 2 theta, so we multiply by that by 2 to get the following. 2 theta is going to be 3,0598 degrees. So here is what we have for the second peak, right? Remember, this table here is for AgBr, which is silver bromide. So for our angle of theta here, we have 3,059, right? For our D spacing, we had 2,8874, 2,8874. like that. So for our third peak here, let's look at our third peak, which is our third peak. We have our third peak at what? 220, and from there we can calculate our d-spacing HKL, which is equals to A divided by the square root of H squared plus K squared plus L squared, which is going to be equals to 5, what was our 7748? Okay, 7748 angstrom. We divide that by the square root of 2 plus the square root of 2 squared plus 0 squared, right? And then from there we are going to divide that 5,7748 divided by the square root of 2 squared plus 2 squared plus 0 squared, which is gonna give us the following: 2,042 angstrom. And from there we can calculate n lambda is equals to 2d, the sine of theta, which is going to be the sine of theta is equals to n lambda divided by 2d, which is going to be 1 into 0,15418 angstrom divided by 2 into 2,042, and this is going to be theta, is going to be the arcsine of the following. Here we have 0,15418 and 2 into 2,042 is equals to the following: 0,03775, and our final answer is going to be the following. The sine or the arcsine of following is going to be 2,1635 degrees. We get our 2 theta from that by multiplying by 2 to get 4,327 degrees here, right? So we're gonna go up and fill that into our table, which is 4,327, and our d-spacing was 2,042. 2,042. And then we move on to 311. So for 311 we have the following, right? We have d HKL is equals to what? A divided by H squared plus K squared plus L squared. This is going to be 5,7748 angstrom divided by the square root of 3 squared plus 1 squared plus 1 squared. Okay, I'm gonna put this into the calculator. 7748, that is correct. Okay, I'm gonna put this one into a calculator and we're gonna have the following: 5,7748, this is the square root of 3 squared plus 1 squared plus 1 squared, right? From there we are going to have 1,741167, right, angstrom. And from there we can calculate our 2 theta from this one, d, the sine of theta, which will be the sine of theta is equals to n lambda divided by 2d, right? And then we're gonna have the sine of theta is going to be 0,15418 angstrom divided by 2 into 1,741167 angstrom, which is going to give us theta is equals to the arc sine of the following. I'm gonna put that into a calculator: 0,15418 and 2 into 1,741167, and put that into a calculator. We're gonna have 0,0443. From there we just put that into a calculator again to obtain the following: 2,534 degrees. And next we are going to multiply that by 2 to get 2 theta is equals to, multiply that by 2, we're gonna get 5,075 like this. This is going to be in degrees. So for our last peak we have 5,075, and for our d-spacing we have the following: 1,7411, 1,7411. So this is our answer for the first given molecule here. For the first given molecule, which is silver bromide, we have our solution for A, right? So this is our A. This is our A. Yeah, this is our A. We are going to have to do the same for this structure here. The table is going to be the same. because they have the same structure. So this part of the table is going to be the same. The values here are going to be different. You are going to calculate them using those formulas, right? So once you've calculated them, you can make sure that your answers are correct by checking the description for the correct answers. But I'm not gonna prolong the video by doing the same thing again, right? We've done it like 4 times, but you're going to have to repeat it for the second value, right? So I'll see you in B in part 2 of the video. Please like the video and subscribe to help out the channel.